So this video is going to cover ionic radius. And so before we talk about ionic radius, we kind of need to talk about ions to make sure that everybody understands what we are comparing when we were talking about ionic radius. So ionic radius are either cations or anions. So please note on the left-hand side of the periodic table, you will find the cations, and on the right-hand side, you will find the anions. Okay, so left-hand side, they lose electrons, right-hand side, they gain electrons. So there is a trend that doesn't have anything to do with the groups or the periods on the periodic table. So write this down in your notes. So cations are generally smaller than their neutral atoms. So cations are generally smaller than their neutral atoms. And then anions are larger than their neutral atoms. So I'm giving you two examples and I'm going to draw them out for you. So sodium has 11 electrons, sodium ions have 10 electrons. While chlorine has 17 electrons, chlorine Cl- or chloride has 18 electrons. So when we are comparing them, we could use the Bohr model to kind of do this. So on this picture here, I have sodium versus sodium ion, okay? So if I'm thinking of the Bohr model, sodium has, again, 11 electrons. Sodium ion has 10 electrons. So when I'm putting them in the circles, I put 2 in the first energy level, 8 in the second energy level, and 1 in the third energy level. Well, as we discussed before, I could take that electron out. That's our furthest away electron. It's called our valence electron. So that is what creates essentially the sodium ion. So I remove that one from the third energy level. And so I don't really have a third energy level for the cation. So again, this one is pretty simple because then it's like the sodium only has 2 energy levels. The sodium ion only has 2 energy levels. Sodium itself has 3 energy levels. So again, it is bigger. So the one that is more complicated is, of course, chlorine versus chloride. So chlorine has a total of 17 electrons and chloride has 18 electrons. So one way you can memorize this is the one that has more electrons is going to be the one that is bigger, okay? Again, in reality, the reason this is bigger, they both have 3 energy levels. And so the chlorine is missing 1 electron. Cl- then has completed the 8 electrons in that third energy level. Really what's taking place is because you're adding 1 more electron to the same energy level, you start to have what they call electron repulsion. And so that is going to spread things out a little bit more. But again, if you just take it as the one that has more electrons, the one that's going to be the anion is going to be the bigger one out of the 2. So that is within itself. So comparing a neutral atom to its ion, these are the trends you're going to see. What you're going to see off the periodic table is, again, within a group or across a period, okay? So I combine them both into one statement, okay? So as you go down a group, ionic size gets bigger. And as you go across a period, it gets smaller, okay? So the claim for ionic size is going to be, again, radius is going to increase as you go down a group and decrease across a period. So evidence, again, is going to be the graphs that you could make. We didn't have you do a graph for this one, so I pulled just a couple elements to kind of compare. So when you look up ionic radius on your Flynn periodic table, again, it's going to be on the back side of your Flynn periodic table. So if you go underneath atomic radius, you will see ionic radius. And so lithium is 76, sodium is 102. So as you can see, you go down, the ions get bigger. As you go from left to right, they get smaller. So lithium compared to beryllium is 76 compared to 44. So again, this is an example of quantitative data, quantitative evidence for this. What's the reason for that? Well, I'm going to refer you to atomic size, okay? So when we talked about atomic size, as you go down a group, you get more energy levels. So if you get more energy levels, even if you're taking the electron away or putting one in, it's still in comparison, lithium compared to sodium ion, they both are losing one electron, but originally their size was different because of, again, energy levels associated with it. So if we take a look at, again, previous videos with Bohr model and also atomic size, lithium has 2 energy levels, sodium has 3. But if I were to remove the 1 electron from lithium to make it lithium ion, Li+, and sodium to become Na+, I'm losing the 2nd energy level here. So I only have 1 energy level for lithium ion, and sodium would then have 2 energy levels for sodium ion. So again, the good news is atomic size is the same pattern as ionic size. So there's no need to memorize anything different. So the only additional information you're going to have to keep track of is the cation is always going to be smaller than the neutral atom, and the anion is always going to be larger than the neutral atom.